Hey everyone. So a bit of a different video. Uh, Essentially, what I want to kind of do in this video is go over the concept of performance, specifically here in SQL Server Management Studio. It's the Microsoft T-SQL, otherwise known. But I mean, this is important for really any coding language, specifically Python, C++. I think you kind of get the gist of it, but I wanted to kind of go over the concept of performance, code performance specifically in SQL, because this is something that I kind of deal with on a day-to-day basis, just at work. And I thought I'd kind of relay this concept, try to attempt at teaching it, I guess, not just for the betterment of my own learning, but also hopefully someone else can kind of learn from what I've learned. So, but regardless, I thought I'd kind of just make this quick video about that. So to kind of get started, I created a database called Performance Test. Very simple. I did a select top 1,000 rows. This is a very small view, so there's not really 1,000 rows. It's only four. But I put an ID, 1, 2, 3, 4. Then I put the fruit name, and this is a table of just fruit names. So I put apple, orange, peach, strawberry. And so this is kind of what I have. I already executed this. This is basically what I'm getting. And so then I move on. So this is the SQL query that I'm actually working with. So to kind of go over just a very basic syntax, I'm selecting all columns. This is what that star basically means. It's a wildcard denominator, but I'm selecting all columns from the database performance test right here. And then basically I specialize it, or I kind of specify it to dbo.fruit, which is just the table, this very small table that I created for this demonstration. And then I kind of set a condition where I say where my fruit, which is essentially this column right here, equals to apple. Okay. Now I already kind of know that apple is spelled with an uppercase A, and then everything else is lowercase. So this is a very specific, it's almost a confirmation bias sort of SQL query, because I kind of already know what to expect. So when I execute this, I think we can all kind of realize, okay, we're going to see this result. But what I kind of want to, I guess, emphasize is the performance of such. And I think something that people maybe overlook, whether you are experienced or new to SQL, or really just coding in general, is the sort of denominators, or I guess the sort of notations, not denominators, sorry, I misspoke there, but the sort of notations that can make a query or code more accurate, or look for more accurate data, so to speak. So in this case, something that I guess I can highlight here is the equal sign. The equal sign in this specific case is basically saying to the query, to the database, saying, hey, I'm looking for this exact match. Now I could do something different notation, such as like. And like is essentially looking for a something similar. If it has apple, say for example. Now it's going to come up with the same thing. I think that's not a big surprise. And there's other things as well that I'm not going to go too far into, but you have these sort of percentage signs, and these percentage signs can look for words, text, you know, things of that nature that are contain this word, right? The word apple. Now, because of how small and specific my database really is, when I run this query, it's still going to come up with the same result. But where you actually see the difference is actually under the hood. So in in this sort of the toolbar, when you go into query, this on the ribbon here on the toolbar, and you come across something called include client statistics. Now this is the shortcut is Shift Alt S. So, but regardless, I'm going to click that. And so when I run, when I go ahead and execute this, it's going to come up with this, and it has a trial. So the trial number, trial 1. So this is the current execution time. This is, I mean, effectively, this is when this happened. And there's not really, you don't really have to worry too much about, the query profile statistics, network statistics. You don't really have to worry too much about that in this case. What you really care about is the time statistics, and this is the total execution time. In this case, you're seeing 10 milliseconds, right? So we're going by milliseconds here, but in this case, it's 10 milliseconds, okay? Now, when we do the same thing, and we get rid of those percentage signs, we just have like, we should see something like this. Total execution time going down, right? Now, if let's say that we have something like an equal sign, we're looking for an exact. Ideally, it should go down, but realistically, because of how small this database is, we can see very, it's going to be very minute differences. It may even go up. So just a bit of a forewarning there. But when we run that, basically stays the same. But regardless, you get my point, right? So in the first example, we use the percentage sign, which is basically just to say, hey, I'm looking for something similar or at least contains this word. We used like on top of that. And so like in that case is looking, again, it's just looking for a similarity. It's not looking for an exact match. Whereas when I use the equal sign, we are looking for an exact match. Now, again, it's very minute, but I guess if you looked at the network statistics, less bytes being sent to the client, you could argue there's a difference there, right? But regardless, the total execution time doesn't necessarily go, up that much more. And you really see this in something such as LeetCode. So if I go ahead, go here, this is something that I submitted. So for example, if we look at, and never mind the notes here, this is just for my own sort of thing, but when we look at the runtime is 437 milliseconds. And this is something that I did, right? So it just to kind of go into the specifics. Basically, this was the SQL. It's a very simple SQL question. So I'm given a table products. I got the column names. That's the type. And then, of course, I'm given the different columns: product ID, low fats, recyclable. So what they're looking for in this LeetCode question essentially is, okay, we want to write a query that finds the IDs of the products that are both low fat and recyclable. So basically are in both of these columns right here. So what I ended up doing in this submission is I selected the product ID from the table's product. Of course, you have to be specific about that. Then I say the two conditions. So where low fats equals to yes, and recyclable equals to yes as well, right? So fits both conditions specifically for the question. Now, this is a very rough, it's not exactly the fastest. I only beat 49, really effectively 50%. Of the submissions here in reality. So, if you have a better solution to this, please feel free in the comments. I am in no means saying that this is the best solution, but this is kind of setting up the context for comparing this query to the other query. Sorry, I just clicked on the notes here. So in the other query, we have like. And in this case, when we put like, it's marginally more, it takes more time, but regardless, it did take a little bit more time. And you see it at least here because at least in LeetCode, they kind of test your code against a whole bunch of other, data sets and whatnot. But regardless, I think the point kind of stands. I think you get the gist of it. Essentially, like versus equal, having the sort of what you see as the percentage sign notation, all those sort of things kind of stack up. And as you're working with larger data sets, they can definitely start to become an issue. But regardless, I think that is kind of where I want to end it there. If you have anything you want to add in the comments, if you have any other solutions, if you just want to ask questions, please feel free. But that's a little bit about performance, a very simple concept of performance in SQL. Um, and hopefully you guys got something out of it. So appreciate all the time. And please let me know anything else in the comments.